Hello everyone. In this video we're going to talk about how pointers can relate with structures. And this video is just going to cover one example, just using structures that represent a complex number and how they react with pointers. So we're going to start by looking at a file called pointer complex. So here we have a structure, starts as underscore complex. The structure has two members, a real and imaginary, both of which are doubles. And then here on line 8, what I'm doing is that instead of having to type struct underscore complex, I rename all of that to capital C, complex with a capital C. So why don't we start with a complex variable. We'll just call it x. And we'll say it is equal to, I don't know, 5 and 7. Now, if we want a pointer to a complex, all we have to type is this. Right, alternatively, we can type this as well. Both allow us to create pointers to a complex structure. If we didn't have the type def, meaning we had to use struct, here's how I would do it, and I'll leave it commented out. Struct complex and then I can do the same thing but with the asterisk next to the data type. Right, so all of these are valid forms of creating a pointer to a complex structure. So now I need to point px to x. So how I can go about that is by typing this. Px is equal to the address of x. So now let's kind of do some analysis on the structure with the pointer to the structure. So the first thing that I want to do is I want to print the address of x. We're going to do it through px. So here what I'll type is just px. Okay? So let's just see the address that we are pointing to. Good. There's no errors. So the address of our complex variable x is this hexadecimal number. Okay, that's not too bad. But let's now talk about the access of accessing a structure. So normally if we want to access the values that the pointer points to, I need to do a dereference. So why don't we try something like that. So we do printf. Since I know that complex x has two positive numbers, 5 and 7, I can say LD plus LD I. Right, so how would I go about accessing the value of P, of the values that are being pointed to by P of X? Well, traditionally I do something like this. Right, and here I dereference the pointer, but what am I actually accessing here? It's pretty ambiguous. Well, I really don't know. So I'll need to specify that. Here I want to access real, and here I'm going to access imaginary. But wait a minute, what's going on here? So with the structure, I'm able to access each member using the dot operator, which is this right here, what's being highlighted. But what's going to go on first? Am I going to dereference px as a pointer, or is my compiler going to think that p of x is accessing imag, and that's a pointer, and it's going to dereference the whole thing? So really the question that my compiler is going to ask is whether I'm doing this. I'm accessing the structure first, and then dereferencing what's there, or if I'm dereferencing first and then accessing the structure, right? And this is ambiguous and this is confusing. But what I really want to do, because p of x points to a structure, more specifically complex, and because it points to the structure, I need to dereference the pointer to a structure so that way I can access the structure. And once I have access to the structure, I can use the dot operator to access the member. So in summary, what does that even mean? Well, what I really want to do is to dereference the pointer to a structure so that way it just becomes a structure. And then once that's done, I should be safe to access the data member. So this second option, which I'm highlighting here, is the correct one. I don't want to do this, right? I want to dereference the pointer to a structure, and then once that pointer is dereferenced, I want to access those values. That's what that error is. So now if we execute the code, right, we get our number correctly, 5 plus 7. This is because we correctly dereference our pointer to a structure and access the member associated with that structure. Right? So here, complex px points to x. So in order for me to access the data at x, I need to dereference. Once I have access to x, because x is a structure, I need to specify which member of the structure I'm going to be accessing. So here I dereference the pointer to a complex, and now we can treat it as just a complex structure. And then here I can access the data members, right, and use them. I can use them plainly as if they were just a structure, right? So this is equivalent to doing something like this. And let me comment that out. We're doing the same thing here. When we dereference p of x, it kind of becomes x because we're accessing the value at that variable, which is pretty neat. But how do the addresses of pointing to a complex structure work? Well, why don't we look at the addresses themselves? I'm going to shorten address to adder. And we will find out the addresses of the imaginary, of each member, not just the imaginary, but the real as well. So things are going to get a little bit complicated. So first I'm going to take p of x, I'm going to dereference it. Now it's a structure. I can access the real part of that structure, and I want to take the address of that real part. Then I want to do the same with the imaginary part. So why don't we take a look at that and see the result. So here we have the address of x, and here we find the address of x real. But hold on, it's actually the exact same address of x. That's pretty interesting. So if we have a pointer to our complex structure x, it actually points to the first member of our structure. And that's pretty cool and a little bit confusing. Something to note though is that x imaginary is right next to it, and that's also pretty neat as well. So the takeaway is that when you have a pointer to a structure, it actually points to the first element of the structure. Another key takeaway is that here, when you have a pointer to a structure and you need to dereference it to access a specific member, this is how you do it. You have a parentheses, asterisk, and then you have the name of the pointer. You close your parentheses, and then use the dot operator so that way you can access whichever member of the structure that you want to. And here you type out which member of the structure that you want to access. But there's got to be a better way. And there actually is. Now, both forms are completely valid, but personally, I think this form that I'm going to show you is much easier to use. So here I have px, which is a pointer to x, and then I do a dash and a greater than 0, so it kind of looks like an arrow. And then I have real, meaning the member that I want to access. And then I do the same thing here. I have p of x, which is a pointer of x, and then I use the dash and greater than symbol, kind of like an arrow, and it's pointing to the other member that I want to access. And virtually nothing's changed. So what does that mean? Well, what that means, and let's see that I can make it a little bit more clear, is that p real is equal to, or well, this dereference is exactly equal to this dereference. And this dereference here is exactly equal to this same way of dereferencing. And that's pretty cool. That's really, really cool. Right, so if I have a pointer to a structure and I want to access the member to it, what I can do is that either I can dereference it kind of the old-fashioned way, but I need to use some parentheses to tell the compiler that I want to dereference first and then access the member, or I can get the name of the pointer, make an arrow to the member that I want to dereference, and they're the same. Personally, over the course of these videos, I'm going to be using this version of dereferencing pointers to structures. But you yourself, you can use whichever version that you want. In the next video, I will determine or show you why it's a little bit easier to use the one that I'm highlighting versus the other, because things can get a little bit more complex. And speaking of the next video, in the next video we're going to talk about using pointers with structures, and we're going to kind of exploit pointers a little bit. We're going to have a structure that's going to be able to point to itself, but in practice is going to point to other versions and other copies of itself, thus creating a linked list. Thank you.